Hello students, welcome back. In this part, we'll discuss more about crystalline solids. We'll see in how many ways the crystalline solids are classified, and we'll discuss more about molecular and ionic solids and the properties of molecular and ionic solids. So let's start. Now let's learn about the classification of the crystalline solids. We discussed about the crystalline solids in detail in our previous part. Now it is the time to learn about the classification, in how many ways the crystalline solids are classified, and also the details of those things. Okay. So the classification of crystalline solids. The crystalline solids are classified into four types. One is molecular solid, other is ionic solids, metallic solids, the covalent or network solids. Okay. The crystalline solids are classified into four different types. So we'll study about one by one in detail. So the molecular solids, you can see in this image, they contain molecules. Ionic solids, they are made up of ions. Metallic solids, they are made up of the CF positive and negatively charged ions, not negatively charged ions but electrons, the CF electrons as well as the positive ions. The covalent or network solids. Okay. So let's, in this part we'll discuss only about the molecular and ionic solids, and the rest two parts we'll discuss in our next part. Okay. So let's first discuss about the molecular solids. Molecular solids, they contain molecules as the constituent particles. So that's why the name is given as molecular solids. The solids which contain molecules as the particles are known as molecular solids. These molecular solids are further classified into three different types. One is non-polar solids, polar solids, hydrogen bonded solids. So there are three varieties of molecular solids, and we'll discuss about these three types of molecular solids in detail. Okay. So first we'll discuss about the non-polar solids. So what are non-polar solids? Non-polar solids are non-polar molecular solids. So they comprise of either atoms, for example argon or helium, or the molecules found by non-polar covalent bonds like hydrogen and chlorine. Okay. So as the name suggests that they contain non-polar molecules. Non-polar molecules, that means the molecule has a net dipole moment is equals to 0. Okay. So that is hydrogen. Hydrogen is, there is a covalent bond between two hydrogens, so there is no any electronegativity difference. So that's why the molecule as a whole is non-polar and is having a 0 net dipole moment. So the solid found by the hydrogen molecules will be a non-polar solid. Similarly, the solid found by the chlorine will be a non-polar molecular solid. So not only the molecules, but non-polar solids are also comprised of atoms. So if you take noble gases, argon, helium, so which are gases at room temperature, so if you cool them, they'll become liquids, and if you cool them further, they'll become solids. So in solid state, if you take solid argon, the solid argon contains argon atoms, right? Argon atoms, and the solid helium contain helium atoms. So these are also considered as non-polar solids. Non-polar solids. So what type of interactions or attractions are present between the molecules of non-polar solids? So this is a question of importance. So we have to know what kind of forces are present between the molecules. So if you take the two hydrogen molecules, if you take, this is non-polar and this is non-polar, but when these two molecules, when they came together, so the electron cloud is going to be distorted, and this will become the temporary dipole as well as the induced dipole. So it will become a temporary dipole, and this temporary dipole will induce dipole in this. So this is a temporary and this is induced dipole. So the temporary induced dipole interaction is also known as the London forces or dispersion forces. So dispersion forces or London forces are the forces present between the molecules in non-polar solids. But however, these forces are weak forces. Since these forces are weak forces, they are soft solids and they are non-conductors of electricity, and they have melting points, they have low melting points because they are held together, the molecules are held together by weak forces, and these are usually in liquid or gaseous state at room temperature and pressure. Okay. So this is about the non-polar solids. So in this picture you can see, this is an iodine molecular solid. So it contains iodine molecules. This is iodine molecule, this is iodine molecule. So they are arranged in this fashion, and thus form is a iodine molecular solid, and which is a non-polar solid because it is made up of iodine, which is a non-polar molecule. Okay. So let's move to polar solids, polar molecular solids, and you can easily understand this polar molecular solids because since you already know that we discussed about the non-polar solids just now. So the polar solids are what? The polar solids are the solids which are made up of polar molecules. Simple as that. So polar solids means they have, the polar molecules means they have a net dipole moment. Their dipole moment is not zero. They are polar in nature. So the molecules of these substances like HCl and SO, etc., they formed by polar covalent bonds. And the molecules in such solids are held together by relatively stronger dipole-dipole interactions. Right? So if you take HCl molecule, it will be like this. It is a dipole where H is delta plus and Cl is delta minus. So the negative side that will be attracted towards the positive one. So that means other HCl molecule will be arranged in this fashion because the positive side will be attracted towards the negative end. So this is delta plus and delta minus. So here there will be a dipole-dipole interaction because HCl is it's a permanent dipole. It's not a temporary dipole because even if you move this one HCl molecule far from this HCl, so but still it behaves as a dipole because it is a permanent dipole. So there is a permanent dipole-dipole attraction. This permanent dipole-dipole attraction is relatively stronger as compared to the weak dispersion forces or London forces, and these are soft solids and non-conductors of electricity, and examples include solid SO2 and solid ammonia. Okay. So this is about the polar molecular solids. So let's move to third type of molecular solid, which is hydrogen bonded molecular solids. So as the name suggests that these are the solids which contain molecules which have hydrogen bonds present in them. Simple, right? So such solids are known as hydrogen bonded molecular solids. So we know that molecules of such solids contain polar covalent bonds between hydrogen and fluorine, oxygen or nitrogen. We know that hydrogen bond is found between hydrogen and a high electronegative element like fluorine, oxygen and nitrogen, etc. Okay. So example, the famous example is ice, solid water, right? So ice has water molecules which are arranged in this fashion, which is a crystalline solid which has hydrogen bonds present between them, right? So at the maximum, one H2O molecule can form 4 hydrogen bonds, right? One H2O molecule can form 4 hydrogen bonds. So these hydrogen bonds are even stronger than the dipole-dipole attractions, right? So that's why these are relatively harder molecules, relatively harder solid, and they are non-conductors of electricity. They are generally volatile liquids or soft solids under room temperature and pressure, right? So this is about the hydrogen bonded molecular solids, which is third type of molecular solids. Okay. So let's move to the second type of crystalline solids, that is ionic solids. So ionic solids, they comprise of what? They are composed of what? As the name suggests that the solids, they are made by ions. So they have positive ions and they have negative ions which are arranged. So ions are the constituent particles in these solids. So yeah, here you can see this is a 3D arrangement, the 3-dimensional arrangement of the positive and negative ions, where you can also see in this picture where the green ones are cations and the other color they are anions. This is positive ions, negative ions, positive ions. So it is a three-dimensional arrangement of cations as well as anions, and these ions are bound together by strong Coulombic force of attraction. Positive and negative ions, they are attracted by Coulombic or electrostatic forces, right? So it is a 3D arrangement of positive and negative ions, that is cations and anions, and these anions and cations are held together by stronger electrostatic forces. Okay, so since the attraction between the ions are higher, so they are hard and brittle in nature. They are hard and brittle in nature. So let's learn some of the properties of the ionic solids. Because of the strong electrostatic attraction between the ions, they have high melting point and high boiling points. We have to heat them to high temperature in order to melt as well as boil them. So they have high melting and boiling points, and they are electrical insulators in the solid state, because in the solid state the ionic positions are fixed. The ions are not mobile in nature. In the solid state, they are held together by the strong electrostatic forces of attraction. So that's why in the solid state the ions, they do not conduct electricity and they are electrical insulators. But whereas in the molten state, or when we dissolve these ionic solids in water, they conduct electricity. They conduct electricity because they become free to move about, and they conduct electricity. So in molten state as well as in solution state when dissolved in water. So students, in this part we discussed about molecular solids. So in molecular solids we discussed about non-polar, polar and hydrogen bonded molecular solids and their properties as well. And we also discussed about ionic solids and their properties. In our next part, we will discuss more about the covalent solids and metallic solids and their properties as well. So keep watching for my next part.